Hi everyone. So today we are going to start Bootstrap World Lesson 8. And again, just like most of the other lessons, you will need WeScheme. You are actually going to start in WeScheme right off the bat for this lesson. So number 1 here says go to this link. So you will need to type this into your internet. And what it's going to do is come up with a pizza shop code. So it says examine the code that Luigi's Pizza Shop uses to determine how much to charge a customer. So this is what should happen when you type in that link. You should get this program, okay? And on our lesson packet, it says click run. And then in the interactions window, we want to evaluate 3 things. So after I click run here, and we wait for it to run, we are going to evaluate 3 things. Okay, so on the right-hand side, the first thing says cost cheese. When I do cost cheese, we get 9. The second thing says cost broccoli, 10.25, and then cost mushrooms. That says that's not on the menu. Okay, so if we go back over here, cost cheese was 9, cost broccoli 10.25, and cost mushrooms, that's not on the menu. All right, so we are going to complete the contract, purpose statement, and examples for the following word problem. Luigi's Pizza has hired you as a programmer. They offer the following pizza toppings: pepperoni for $10.50, cheese $9, chicken $11.25, and broccoli $10.25. Write a function called cost that takes in the name of a topping and outputs the cost of a pizza with that topping. So my function name is cost. It's taking in a pizza topping name. So that would be considered a string. And it's going to produce the cost of the pizza. So that would be a number. All right. Now our purpose statement here is that it produces the cost of a pizza with a given topping. All right, so we got a couple different things here. Since we have 4 different toppings, we need to create 4 different examples because there's 4 different things going on here. So the cost of pepperoni, if I type pepperoni, looking back at that problem, pepperoni costs $10.50. So what the function should give me is $10.50. So if I do cost cheese, cheese was $9, so that should give me 9. Cost chicken, chicken was $11.25. And then cost broccoli, we get $10.25. All right, so if we circle the changeable part of the examples above and then come up with a variable name, we find there are how many different changeable parts? So here we changed the topping and the amount, right? So there are 2 changeable parts, the topping and the price. So let's use those as our labels, topping, price. Okay, so since the domain of the function only has 1 input, right? Like I'm only inputting the topping. we can't use two variables. So that's where this gets a little tricky. So since the price, which is our output, depends entirely on the topping, which is the input, then the price is what we call the dependent variable. Meaning the price depends on the topping that is chosen. The topping is what we call the independent variable. Meaning the topping does not depend on the price. All right. The cost function makes use of a special language feature called conditionals. The abbreviation for conditional is COND. Each conditional has at least one clause. Each clause has a Boolean question and answer, meaning it's going to give you a true or false statement. Square brackets enclose the question and answer for each clause. In the cost function, there is one clause for cheese, another for pepperoni, and so on. If the question evaluates to true, the expression gets evaluated and returned. If the question is false, the computer will skip to the next clause. The last clause is in a conditional can be an else clause, which gets evaluated if all the questions before it are false. Looking at our function, that would mean if people don't order pepperoni, cheese, chicken, or broccoli, then we can program the computer to charge a set amount. How much do you think Luigi should charge if someone orders a topping that is not on the menu? So you can make your choice for that. I don't care what it is. So how much do you think Luigi should charge if someone orders a topping that's not on the menu? Here we're going to define our cost function because we haven't defined it yet. So again, we are defining cost based on the topping, but we have conditional statements here. Okay, and the way we write this, we have our square brackets. So we have string equals question mark, topping, and our first topping was pepperoni. And if that comes back true, it should return $10.50 because that's how much it was. Okay, so the second thing was cheese. So everything's going to stay the same except for pepperoni and $10.50 will change to cheese and $9. So string topping cheese $9. Okay, next one, same thing, string equals question mark, topping. Our next one was chicken. And chicken is $11.25. And our last topping, string topping, broccoli. And that is $10.25. Now, obviously we know there are more pizza toppings than these four things. So your last statement is going to say else, and then whatever number you did from above here. Okay, so let's say you said he was going to charge $15. So we can say else 15. Okay, so let's look at the cost function we just did right here. How many clauses are there for the cost function? So you want to see after the conditional statement, how many lines of code do we have here? 5. Okay, so part B says identify the question in the first clause. So the first clause is saying string, topping, pepperoni, 10.50. So that first clause is saying, is the chosen topping pepperoni? If the chosen topping is pepperoni, the code would return 10.50. If not, it would move to the next line. So the second clause is asking, is the chosen topping cheese? Okay, so that's what these clauses are doing. Number 10, functions that use conditions are what we call piecewise functions. And piecewise functions are something that were very, very popular in algebra. So we should also recognize that language. So why are piecewise functions useful? Think about the player in your game. You would like the player to move one way if you press the up key, another way if you press the down key, another way if you press the right key, and another way if you press the left key, right? We want him to actually move that direction. Without conditionals, you could only write a function that always moves the player up or always moves it down, always left or always right, but not a combination of these movements. Okay, so now that we know how to use conditionals, let's begin writing the code for update player. When the arrow keys are pressed, the player will move 20 pixels in the appropriate direction. So when the up key is pressed, think about your axes. When I press the up arrow on my computer, what happens to the player's coordinate? What changes, the x value or the y value? And if I'm moving up, that would change the y value. So x would stay the same, and the y value would increase by 20 because we're moving 20 pixels. Okay, so part B, when the down key is pressed, what's going to happen to the coordinate? Almost the same thing as the up key. X stays the same, but y is going to decrease by 20. Okay, then the opposite of this happens with the right and left key. Y is going to stay the same, but the x value is going to increase and decrease. So if we go to the right, x increases by 20, y stays the same. And then if we move to the left, x is going to decrease by 20. Y stays the same. Okay, so we are going to be using a function called make position that the computer already knows, just like the computer already knows what plus, minus, times, divide, less than, greater than, equal, star, rectangle, circle, bitmap, URL, etc. So it already knows what this function does. Okay, we just have to write the software essentially. So the make position function tells the computer to make the position a certain place on the screen. For example, if we typed make position 300, 140, the computer would move the object to the point 300, 140 on the screen. Okay, so essentially it's saying I want this object to be at that coordinate. So to move the point 300, 140 to the right 20 pixels, what are we going to have to change? So think if I'm moving to the right, are we changing 300 or are we changing 140? Remember, my points are x, y. So x is first. So if we're moving to the right, we said the right, the x value is going to increase. So we need to add 20 to 300. So my code would be make position. I got to move 300 to the right 20. So we got to add 20. So that would be plus 320 and my y value stays the same, 140. Okay, so essentially that's what we're doing. We're changing the coordinate of the object depending on the direction we want it to move, right, left, up, or down. Okay, so this is all we are going to do today. So make sure you have all 3 of these pages written down in your lesson packet so that you can take advantage of it tomorrow when we start to actually write the code. Okay, if anyone has any questions, please let me know.